Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready to go?
Hello, Mr. T here with another tutorial. Today we're talking about complex fractions. We'll be talking in a second about our procedure for working with complex fractions, but let's first look at what some examples might be. Complex fraction is essentially a fraction divided by another fraction. So it's a fraction where the numerator and denominator is composed of fractions. Now this could be just a fraction with numbers and no x's, or it can be rational expressions. So this is a simple one. We'll be looking at something a bit more complicated, and then our last one will be even more complicated. So we're going to talk about how do we simplify these rational functions, or these complex fractions. So to simplify, we want to start out by simplifying the top of the fraction, the numerator, and the denominator separately. So we'll just work with them as separate problems using our addition and subtraction rational expression skills, and also if there's anything that can be factored and simplified, we would look at that. Now these complex fractions are essentially a fraction over a fraction, but that is just division. And in our tutorial on dividing rational expressions, the way we did division of rational expressions was to rewrite them as a multiplication problem. And we turned the division into multiplication by taking the numerator and multiplying it by the reciprocal of the denominator. So we'll be doing that here. And then we'll just use multiplication procedures that we had to simplify and get our final answer. So let's look at some examples here. Now in this case, the first step of simplifying our numerator and denominator is there's nothing to do. So we're ready to do our second step, and we're going to turn it into a multiplication problem. So we're taking our numerator and we're multiplying it by the reciprocal of the denominator. Now we look to see, can we cancel? So here we have an x to the first power and an x to the second power. So I can cancel this x out, and I'm canceling one of those out, so I have x to the first. And now we just multiply across, so we have 4 over x. And that's our final answer. That's the simplified form of this complex fraction. All right, let's look at something slightly more difficult. So here, our numerator, we have a single fraction, because we can make it a fraction by putting it over 1. But down here, we have an addition. Remember, to get addition, we need a common multiplier, a common denominator. So I need to multiply this fraction by 9 over 9 because I'm missing this 9 over here. And in this fraction, I'm missing the m. So I need to multiply by m over m. So in our denominator, if we simplify this, I've got 9 times 3, I've got 27 plus 25m, and that's over my common denominator, which is 9m. So I've replaced this entire denominator. I've replaced that with this. So now I need to take my numerator, which I'm going to write as a fraction by putting it over 1, times my denominator, but I need to take the reciprocal of the denominator. Now remember, we can't cancel these m's here because we have addition here. We can only cancel when we're having factors or multiplication, and we can't cancel here. So we now just multiply straight across. So we have 9m times m squared would be 9m cubed. In the bottom, we have 1 times this expression, so we just have this expression here. And that's as far as we can go. There's nothing more we can do with this one. So again, we've turned a complex fraction into a simple or single fraction. All right, let's look at our last one. Now in this last one, we've got a expression in the numerator which we have to add in the bottom. So it gets a little bit busy. So you can off to the side rewrite. So now I got this fancy thing here, so I can drag the numerator over here and we can simplify that. So to get my common denominator here, I'm missing a 5 in the denominator, so I have to multiply by 5 over 5. And over here, I'm missing this 4, so I have to multiply by 4 over 4. Now remember, it's going to be 4 times that entire thing. So we have here 5 times 5 is 25. And here I have to distribute my 4. 16. And at the bottom we have 4 times 5, or we can turn that into 20. And if we simplify that, we've got 4x plus 41 divided by 20. So that's going to be our numerator. Let's now simplify our denominator. So let's pull that off to the side. We want to do the same thing again. We need to get a common denominator. So I'm going to multiply this by 4 over 4. Again, 4 is times the entire thing. And I'm going to multiply here by 5 over 5. Now since this is a subtraction, I'm going to make it the addition of the negative of this. So I'm going to put that negative right here. So now on the top, if I distribute, I have 4x plus 16, and here negative 5x, and negative 5 times negative 3 is plus 15. That's over 20. So if we simplify that, we've got negative x plus 31. That's all over 20. So now we can pull this together because we have this was our numerator, and this is our, whoops, I just want to take this part here, so let me just select that part. Well, it's not going to let me take that, so let me just go do it the old-fashioned way. We'll rewrite up here. So I've got negative x plus 31. So we can not cut off the top of our problem. So remember, we're going to turn that into our numerator times the reciprocal of our denominator. And I'm going to write this as 31 minus x. We don't normally have a leading negative, so I could either factor out a negative 1 or write it as I did here. Now our 20s will cancel out, and we're left with a final answer of and again, we can't cancel x's here because I've got addition and subtraction on the bottom. So this is our final answer. So not too hard. You've just got to take it step by step. Work with the numerator, work with the denominator, and simplify those as far as you can. And then again, the key step here is turning this division into a multiplication of our reciprocal. So good luck on working these problems.
Are you ready? Are you ready? Oh, oh.